Assalamu alaikum, dear students. Once again, Mr. Atiq, welcome you all for the weekly plan. As you know that we have chapter 22, section 2 in a continuous manner. We will continue section 2 again. And according to the weekly plan 10, we will cover in this week the pages from 677 to 682. Again, the names of alkanes. As we studied before, the alkanes, alkenes, and alkynes. I give you already a clear view about this thing. These three terminologies: alkanes, alkenes, and alkynes. Now look at the names of alkanes. Number one, methane, A-N-E, methane. Molecular formula is CH4. Structure formula is C branched HH4. Look at CH4, C is 1, and H4, 4 are subjected to this carbon atom. But as it is a hydrocarbon, pure hydrocarbon, that's why C is considered to be the backbone for this thing. Melting point is minus 182 Celsius and boiling point is minus 164, so which can be helpful for you guys as far as your SAT exam is concerned. Now the second one is ethane, C2H2, ethane, A-N-E, ethane, C2. Like C2 means what? Like there will be 2 carbon atoms and 6 will be subjected to both of them. Look at C and C2, C, and then H, like 6 carbon atoms. Melting point is minus 172. Boiling point, like BP, is minus 88.6 Celsius. Respectively, propane, butane, and pentane. We have. These are the formulas, molecular formulas. These are the structure or branch formulas. These are the melting points, MP or PP as well. Come to the second. Systematic names of alkanes. Branched chain alkanes nomenclature. The naming of branched chain alkanes also follows as the names suggest. Follows a system method. It follows what? A system method. The hydrocarbons branches of alkanes are alkyl groups. Remember alkyl groups, okay? Alkyl groups are what now? Look at alkyl groups of atoms that are formed when one hydrogen atom is removed from an alkane molecule. Come to the previous slide. For example, if I'm gonna to remove this one H from this CH4, look at these are 4. If I'm gonna to remove this H, it will be what? Then it will be C, just one H, and H only 3 will be here, so it will be known as what? Alkyl then, okay? Like methyl. Look at the name methane there, it will be known as what? Methyl. Alkyl groups are named by replacing the suffix A in E of the parent alkane with the suffix YL. Of course, it's okay, so easy. Alkyl groups names are used when naming branched chain alkanes. What? Branched chains alkanes. Alkanes, and these are the names. Now look at, you will see how the A in E is going to be changed by YLE. How are we going to replace this suffix A in E by YL? Okay. CH4 methane, CH3 bond, CH3 ethane. Like ethane, we studied that there will be 2 carbon atoms, C, and 6 hydrogen atoms attached to it or subjected to it. Then the propane, C. Look at CH3, single bond CH2, single bond CH3. How many carbons are there? 3. We call them what? Propane. And how many hydrogen atoms are here? 8. So look at, now consider the first, methane, methane, A-N-E, methane. Now look at the branch, the bond, CH3. Look at Here it was CH4. Once we removed only one hydrogen from here. Now we call them what? Methyl. Look at methane being changed to methyl, YL. Now similarly, ethane, A in E, will be changed into bond CH2 minus CH3. We call them what? Ethyl. What? Ethyl. Similarly, propyl, butyl and pentyl respectively. Now systematic names of alkanes, branch chain alkanes nomenclature. Branched name of alkanes nomenclature. The three, look at CH3, CH2, CH2 dash CH3 H dash, look like C, CH3 CH, here H as well, here CH as well, and CH3 CH3. These are what actually the branch chain, how the branches occur from the main F acid. Look at from the main branch. Look at these are known as what? The branches. Look at this is a single branch. Now it's been divided into two more. What we call them what? Branched alkanes. Okay. How the nomenclature will be there? The three CH3 groups are methyl groups. It's okay. The CH2 and CH3, it will be known as what? The ethyl group. Ethyl group. Now look at 1, 2. This is ethyl. 1. This is what? Methyl group. 1, 2, 3. Methyl group. Now branch chain alkanes nomenclature. To name the parent hydrogens, to name the parent hydrocarbons, add the suffix A in E again similarly to the correct prefix in the case of OCT for an 8 carbon parent chain. 8 carbon parent chain. Octa. Octane. Octane like 8. If you consider this one, 1, 2, 3, 4, 5, 6, 7, 8. Or from here, 1, 2, 3, 4, 5, 6, 7, 8. Got the idea? So these are what? It will be known as what? 8 carbon parent atoms. Now identify and name the alkyl groups. Branch chain alkane nomenclature. Arrange the names in alphabetical order in front of the name. Of the parent hydrocarbons. Ethyl, methyl, octane. Ethyl, methyl, octane. To show that there are 3 methyl groups present, attach the prefix tri. 3 methyl groups are present, so 3 means what? Tri in chemistry or in any science terminology. Look at the first one, we call them what? The first one, uni, or you can say the one or the first. Second, di, T, di, D-I, di, or D-I-A, dia, like 2. Tri, tri, then tetra, then penta, then hexa, then hepta, then octa, then nano, and then deca. So tri we have, okay. So if there are 3 methyl groups present, we will use the tri prefix to the methyl name to form trimethyl. Ethyl trimethyl octane. Now look at properties and usage of alkanes. Don't get confused. Alkanes we studied in the hydrocarbons jurisdiction. Remember, it has single covalent bonded things. C, of course, it will be like the main F acid. Don't get confused for the branches as well. Now look at, these are the most important usage of alkanes, mostly for the SAT students, or they can ask you generally as well. Properties and uses of alkanes. How we can use alkanes in different daily lives. The carbon hydrogen bonds of alkanes are non-polar. There is no polarity at all, of course. So alkanes molecules are non-polars. They are non-polars. There is no polarity like plus and negative ions or ionic charges. The only forces of attraction between non-polar molecules are weak. Let me arrange again for you guys. This one. Yeah, it's okay. The only forces of attraction between nonpolar molecules are weak London dispersion forces. Small, weak London dispersion forces. London dispersion forces are stronger when the molecules are larger. So physical states of alkanes are here are a function of their molecular size, like it depends on the molecular size. London dispersion forces are considered to be like this, the weak forces, but it will be stronger enough for the larger molecules as if their physical states or the molecular size it become larger, so it will be stronger then. Come to the physical state. One is chemical states, like like how it tastes or this or that, how I think can be changed from one state to another. We call them what, like they are chemically changing something here, but physically, like you can see something. Okay, physical states. Alkanes that have the lowest mass, those with 1 to 4 carbon atoms, are gases. They are gases here. Okay, now look at the first one is natural gas. Natural gas is a fossil fuel composed primarily of alkanes containing 1 to 4 carbon atoms. Larger alkanes such as gasoline and kerosene are liquids. Of course, alkanes that have a very high molecular mass such as paraffin wax are solids. Some wax are considered to be like solids. Understand, they are that much stronger enough. It seems to be like in liquid form, but it will give you a shape that looks like it will be like they are solids. Properties and uses of alkanes. Number 1, the boiling points. The hydrocarbons molecules in petroleum contains from 1 to more than 50 carbon atoms. Oh, this is so big, you can say, or so large, you can say. Boiling points, look at how it ranges. It ranges from 1 to 50 carbon atoms, which is like you can say like a big branch. It will from 1, the boiling point will be just like you can say not that much high, but when it reaches up to 50 carbon atoms, how come it, like how it will be possible? How much they will require a temperature to become change from one state to another state. Here usually in chemistry I studied by myself as well, the fractional distillation of crude oil, in which we give like to a crude mud, which usually in Saudi Aramco they are just like extracting the mud. Okay, like they are, you can say, purple in shape, or like dense diesel in shape, like gray in shape. Understand? So by giving them different temperature, after passing them through different temperatures, they will give you like different ranges of petroleum substances or petroleum products. Their gasolines are there, gasolines are there, different kinds of oils are there. The last residual left is the that charcoal, which we are using for the metaling of roads. Okay, this trench allows the separation of petroleum into different portions that have different boiling point ranges. Of course, as I told you, look at here we have in fractional distillation. As I told you, I did a project over this thing. Components of a mixture are separated, look at, as I told you, by giving them different temperatures on the basis of boiling points by condensation of vapors in fractionating column. Now we have unsaturated hydrocarbons. Now hydrocarbons or saturated hydrocarbons being finished. Now we have unsaturated hydrocarbons. Hydrocarbons, they don't have contain the maximum amount of hydrogen are referred to as unsaturated one. Remember the difference. Hydrocarbons, they do not contain what? Do not contain a maximum amount of hydrogen are referred to as unsaturated one. Unsaturated hydrocarbons are hydrocarbons in which not all carbon atoms have 4 single covalent bonds, not all of them. And unsaturated hydrocarbons has 1 or more double bonds. Like look at the double bonds phenomena arises here. Like look at that has 1 or more double bonds. This double bonds. This means, and look at the unsaturation means that we are gonna to approach towards alkenes. Until now we discuss only 1 single bond. Okay, most of them contain hydrogen atoms. Here we don't have any like larger number of hydrogens, and the bonds will be changed to from 1 to 2 or 3 or triple bonds between carbon atoms. Carbon atoms can easily form multiple bonds to other carbon atoms. Okay, so multiple bonds in organic compounds are common. What? They are common. Okay, it is a very interesting topic, by the way. Okay, now look at, finally alkenes are here. Okay, we have alkenes now. Let me shade it. Let me give them some name as well. Okay, alkenes, double bonds. Remember what? Double bonds. ENES or ENE. ENE. What? This ENE means what? That we have. Oh, let me just write for you guys. Bonds phenomena. We have a double bond phenomena. Okay, alkenes double bond phenomena. This is from my side, like this double bond. It means what? That we and alkenes usually have double bonds. Alkenes are hydrocarbons that contain double covalent bonds. An alkene with 1 double covalent bond or 1 double bond has 2 fewer hydrogen atoms than the corresponding alkanes. Look at this is the main difference. C3H4 H8, sorry, C3H8. C will be 3 and H will be 8. Now look to count. C 1 2 3, so C3. H8, so 1 2 3 4 5 6 7 and 8. Now look at here we have double covalent bonds. These are just a one formula for the alkane. Now look at the same alkane will be transformed into alkenes. C3H6 1 2 3. Look at the double bond. 1 2 3 4 5 6. This is what? C3H6. Now we have double bonds. The general formula for non-cyclic alkenes ENEs with 1 double bond is CnH2n instead of CnH2n plus 2. This plus 2 was for alkanes. Now look at, we remove this plus 2. That's why the structure formula being devalued or degrade to H6 now. Look at, if we implement C3 here, like N is the number of carbon atoms, and H2N, like H can give you what? Like the hydrogen numbers. So if we give like 3 here, it will give us, or plus 2, it will give us like C3H8. This formula was for the alkanes. Why I skip this thing? H 2N. Look it is for alkenes. Remember again, CN H 2N plus 2 is for alkanes that we discussed. Okay, let me just to give you this one. Got the idea? Remember, these are the general formulas. Okay, now this one is alkane, basically. What? Alkanes. Now this thing these are alkenes. Wow, now look at this formula is for this one. Yes, and is for alkanes. Alkanes has this formula CnH2n plus 2, and alkenes has CnH2n respectively. Now come here. Systematic names of alkenes. The rules of naming simple alkenes are similar to those for naming an alkane. Similar, okay, like for naming alkanes. For the purpose of naming an alkene, the parent hydrocarbon is the longest continuous chain of carbon atoms that contains the double bonds. Of course, pentene, hexane. Pentene and hexane. Look at the difference. This is what pentane, okay. These are the rules for this thing, by the way. Look at pentene. These are not hexane. Sorry. These are, it will be known as what? Pentene. 5, okay. Not hexene, you can say. Understand? Like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So pentene, not the hexane one. Here, systematic names of alkenes. If there is more than one double bond in an alkene, the suffix of the name is modified to indicate the number of bonds. 2, what? Adene. 3, atrine, and so on. Like 1, 2, 3, 4, 5. This is obvious that we will use penta. 5. Okay. But from where we will start? Look at this. 1, 4. Pentadiene. Pentadiene. Now look at from where? From here. 1, 2, 3, 4. From here 1. We will study what? That this is 1. Again 2, 3, 4. 4, so 4 will be here. Now count 1, 2, 3, 4, 5. So penta, but the double bonds are here at the 4th stage and at the 1 stage, or in the one, or on the 1 branch, or at the 4th branch. That's why we call them what? 1, 4, 2, 3, 4, 5. Pentadiene. Because we have double bonds. If there would have been like another here like like double bonds, another one. So we know is what? 1 2 then 3. So 1 3 and then 4. 1 3 4 pentatriene. What? Pentatriene then. But we have double bonds, so that's why we have diene, double bonds. Okay. Now properties and uses of alkenes. Alkenes are non-polar and show trends in properties. Trends, okay, like changing or different properties at different scenarios. Okay, now come here. Similar to those of alkanes in boiling points and physical states. Boiling points and physical states. Examples: alpha farnesene, a solid at room temperature, is found in the natural wax covering of apples. Covering. Look at natural wax covering of apples. Now this is the branch structure for that thing. 1 2 3 4. Wow. Okay, this is the structure for farnesene. Anyhow, these were today's topic, and the next inshallah we will study the alkyne. I'm going to edit this video for you again by including different slides for the alkynes as well. So remember, for the alkynes you need to subject yourself to books. The point is that you need to study the alkane, A in E, alkenes, E in E, and Y in E, alkynes respectively, single bond, double bond, and triple bonds. Okay, these are so much interesting topic, by the way. Okay, see you then. Fi aman Allah.